Hey everyone, welcome back or welcome to my channel. Sorry if you can hear the heater going on. It is very cold outside. It is minus 23 degrees Celsius. Colder than that with the wind chill. In today's video, we're actually going to be talking about the difference between correlation and causation and why this concept is so fundamentally important to not only biochemistry but really to all of the sciences. So we're first gonna define what these two terms are. I'm going to give you 3 examples, 2 of which actually involved our vaccinations. One example is around childhood vaccination. The other example revolves around flu shots. The third example is actually going to be a personal example around me and my IIH. Let's get into the video. The goal of any good science class is to first define your terms. So correlations are those type of phenomena where you get one variable and another variable that appear to share something in common, but they're not directly related to one another. So if you were to look at a graph, you're going to notice that there's some patterns in common, or they may be sharing a similar type of cause, but they're not necessarily directly related to each other. Meanwhile, in causation, you have one circumstance directly leading to the outcome in the second instance. So the first example that I referred to was in childhood vaccinations. With anti-vaxxers, they tend to mix up this correlation versus causation. Andrew Wakefield and his debug study now actually put vaccines directly lead to autism, as if that's a causative occurrence, when in fact we know that there is no relationship at all between vaccines and autism. So this is one thing where parents in particular will see their kid get their vaccinations at a particular time that autism actually tends to show up, and then they'll try and think back basically to, well, what could have caused this? And the only thing they remember is getting the vaccination. So the vaccine obviously caused the autism. No, hold on, wait a second. Absolutely not. No, this is not a causation effect. That is a correlation. So when you've got 2 separate events appearing to be related, when in fact it's just probably the age that the child is at, that they just happen to be showing the symptoms at the same time they get their shots. The second example I give is with actually adults who tend to refuse the flu shot every year. With the flu shot, generally, people tend to think that, well, I got my flu shot, why am I still getting sick? Keep in mind that influenza is not the same as a cold. So you get your flu shot, but then you don't feel well. So did the flu shot give me the flu? No. Hold on. No, it did not give you the flu. You got a cold, but it takes a few days for the cold to come to show symptoms. So, again, one event and another event are related, simply happening at the same time, but they do not share the fact that one is directly leading to another. Example actually revolves around an example around my IIH, or idiopathic intracranial hypertension. So if you remember from my IIH diagnosis video, I will link that in the description below because I have actually referred to that before. In the diagnosis, you remember me talking about in the preview that I had a UTI. I was put on macrobid for that UTI, and it turns out that macrobid, or nitrofurantoin, can actually cause IIH in a very rare amount of people. It's actually only at about a 1% chance, but being that it's still possible, it's still maybe the fact that it may have caused my condition. It's a matter of I took the antibiotic and then the symptoms started showing up. With the macrobid, again, it's exactly like the flu shot example, where you have one event that happens, and then you have another event that happens, and they appear to be related, but one may not be directly going to the other one. You may be wondering, why spend all this time talking about the relationship between correlation versus causation? Well, there's actually a concept called spurious correlation, where 2 events appear to be related if you were to graph them, they would have the perfect synchronicity, when in fact they don't share anything in common at all, and it's just they are a correlated event, but they're not actually significant correlation to where you want it appearing in your data if you're looking for something that might be significant. The best type of study, and I'm going to get into studies fairly soon because we must cover studies before we actually move much deeper. But in studies, you have placebo, where it's a fake treatment used, and it's basically to rule out the mind. You need to make sure that drugs actually work. And then you actually have studies called meta-analysis that actually look for different reasons for a cause among many different studies. So the best types of studies that are actually done are meta-analysis for determining causes. So we're going to get into studies probably in the next science-related video just because they are that important. And you really must know the basics of a scientific study before we go much further. I really hope you enjoyed this video. I really hope you get something out of these basic introductory science type videos. They're probably one of the most fundamental parts of learning science. Now, if you haven't checked out my diagnosis video, definitely go check that out now. Bye, everyone!